This question states, for an element with plane strain of epsilon x equals 20 microstrain, epsilon y equals 15 microstrain, and gamma xy equals 5 microstrain, use Mohr's circle to find the largest principal strain. Well, let's go ahead and rewrite what the state of strain is. We'll say that we have epsilon x equal to 20 times 10 to the minus 6. So that's going to be 20 microstrain. Epsilon y is equal to 15 times 10 to the minus 6. That's 15 microstrain. And gamma xy is equal to 5 microstrain. What is the first thing we do when we figure out when we start working with Mohr's circle? Well, probably to figure out what the epsilon average, or when we're doing stresses, we figure out what the average stress is so we can figure out where the center of the circle is. So epsilon average is going to be the average of epsilon x and epsilon y, so that's 35 divided by 2, so that's about 17.5 microstrain. And once we've done that, we might as well go ahead and draw our epsilon and our, not epsilon, gamma xy over 2. And actually, we'll just call it gamma over 2, like that. Okay, for axes that we're going to use for Mohr's circle. The average that we're interested in, we can put about here. And we can also mark out the epsilon x and the epsilon y. So if you think about it, it's a pretty tight Mohr's circle because we're going to come in with this being 17.5 microstrain, and then equal and opposite distances on either side. Whoops, I lost my slide. Okay, we can put in here, and we can put in, or let's put it this way, we can put in, that's actually, here we go. Okay, so this is going to be the epsilon x, and then we'll have another line, dashed line. Whoops, that's not very good. That's not quite symmetric. Here, where we have like that, this would be epsilon y, like that. Okay, so we're going to use the epsilon x, or are we other things? Epsilon x and our epsilon y appropriately, as we've seen here, with our gamma xy. Okay, now this is gamma xy equals 5. All right, so gamma xy over 2 would be down at essentially, well, gamma xy over 2, right? That would be this divided by 2, right? So gamma over 2, right, is going to be equal to 2.5. So it's positive, so gamma xy over 2, this is going to be 2.5, like that. Okay, so we can draw this and this about like that, and then make a circle. That's not a very good circle, but you get the idea. Okay, like that. And so this will give us the opportunity to figure out what the radius is. What is the radius going to be? Well, it's going to be the adjacent side. All right, we'll call this just adjacent, and this is the opposite side. Right? So we have for r, the square root of the adjacent squared plus the opposite squared. What is the adjacent? Well, the adjacent is going to be the, here's the mouse, all right? It's going to be epsilon x minus this average, right? So that's only 2.5 microstrain. So we have like that, okay? And I'm missing parentheses, okay, like that. And then that's the opposite is going to also be 2.5 squared, like that, okay? And if we do this out, um, what we would see essentially is square root of 2 times this original quantity. So so the original quantity being 2.5. So square root of 2, 2.5 times the square root of 2. This comes out to be something like 3.16. And I guess I can be more careful. I can say, all right, times 10 to the minus 6. Okay, and this is going to be 3.16 times 10 to the minus 6, or 3.2 about microstrain. So we've calculated out the radius, and if we need to figure out the largest principal strain, as indicated here, then what are we going to do? We say, oh, well, that will be the average, the center, plus r, because this is where the largest principal strain will be. Okay, so the largest principal strain will be the sigma average plus r. Well, uh, did I say sigma? I mean epsilon average. That's 17.5 microstrain plus r, which is, as we said, 3.16 microstrain. And this comes out to be about 20 point, well, I guess it would be 66, but 20.7 microstrain. And that's going to be the largest principal strain. What have we done here? Well, we have taken a state of in-plane strain. We've used Mohr's circle and calculated what the radius of that circle is, calculated where the center of that circle is, and then we've been able to calculate out the new value for the largest in-plane principal strain, which, if we think about it, as long as the other strain that might be involved in as long as the other principal strain. Okay, so we have one principal strain epsilon 1, we have one principal strain here, so we could say, okay, so this value right out here, this would be giving us the epsilon 1, or we could even say it's epsilon 1 there, and this value right here, that's going to be the epsilon 2, as long as the other value, epsilon 3, is at the origin or somewhere in between epsilon 1 and 0, or maybe even epsilon 1 and minus epsilon 1, then we could say that epsilon 1 in fact is the largest principal strain. Thank you. I hope this is useful.